Our last lesson for this week, advanced math students, is going to be lesson 78. After this lesson, we're going to be going ahead and taking our next test here. So the next 2 days will be review days for us, and then you'll be taking that test after that. I try to make this one a little bit shorter material as to lesson-wise because there's been a lot of things that we've talked about. Now, over a number of lessons here, we've talked about some different kind of geometric shapes. We've talked about circles, we've talked about parabolas, and recently we talked about an ellipse. Today in lesson 78, we're going to talk about another kind of geometric shape, and that one is called the hyperbola. Now, before we get into our discussion of the hyperbola, I want to review something from lesson 71 that we talked about with regard to the ellipse, as we're going to see some very similar comparisons when it comes to our discussion of the hyperbola today. Remember what the ellipse looks like? It was an oval, and that oval either was along the x-axis or it was along the y-axis, depending on the standard format that you had. The standard format was written in two different ways. They both involved the x squared and the y squared in the numerator. The letters A and B were in the denominator, and we'll review what did those mean in just a second. And these equations had to equal 1 in order for it to be in standard format. Another thing about the ellipse in the equation, there had to be plus signs in between our fractions. Today for the hyperbola, they're going to be minus signs between those fractions, and that's why it's going to change into another shape. Now notice between those two equations, the only difference is the location of the letters A and B. In the first equation, the A is underneath the x. In the second equation, the A is underneath the y. Why did we have two different equations? Because the A always told us the major axis. When the A was underneath the x squared, the ellipse was longer along the x-axis. When the A was below the y part of the question, the major axis was the y-axis, so it was taller than it was wider in the question. The B gave you the length along the minor axis, which was the shorter of the two axes that you had in the question. Remember, to find those values of A and B is what did you square to go into the denominator. Like if it said x squared over 9. Well, what did we get for the number 9? How do I square something? It was the number 3. So I would move 3 to the right, 3 to the left, or possibly 3 up and 3 down as we're looking at our question for the ellipse, like we had graphed back in lesson 71. Well, let's go ahead and take a look at our new idea for today with this hyperbola. We're going to notice the equations almost look identical. There's just one slight change, and it's going to be that minus sign that we have instead of the plus sign in the middle. That's one of the things that's going to be different. The graph of a hyperbola is going to be formed between two curves, and those two curves are mirror images of each other. And when we actually get to see the question, I'll explain that a little bit more clearly than right now here in our lesson. As we're looking at the hyperbola, there's two different formats that you could have, just like there was two different formats for the ellipse. The format that you have is going to tell you where these two curves are going to be on the Cartesian plane. The first format that you can have, the center is still going to be at the origin, just like it was for the ellipse, and it says the foci is on the x-axis. So what we kind of want to think about, the graph that I'm going to draw is along the x-axis. That's where those two curves are going to be located. This is what the equation is going to look like if you're along the x-axis. Notice it says x squared over a squared, then it's minus y squared over b squared is equal to 1. In your standard format, the equation still has to be equal to 1, but now we have that minus sign that is in between the two fractions instead of the plus sign. The plus sign is what led us to the ellipse, the oval shape. The minus sign is going to lead us to the hyperbola. Just to kind of give you a rough picture of what this is going to look like, this is how it's going to represent. Because the x squared is in front of the subtraction sign, that means those two curves that are mirror images of each other are going to be on the x-axis of the question. So I'm not really worried about where are the A and where are the B in this question, because actually the A is always going to come on the first fraction, the B is always going to come on the second fraction. It's the location of the X and the Y that we have to worry about for the hyperbola. So if you notice the x squared is in the first fraction, then that means your graph's going to look like the one that I have on the screen, that those two curves are drawn along the x-axis. So this is what it would look like if I need to be on the y-axis. Again, we're centered at the origin. We're not going to move things around too much here, but now the only difference is the y squared is first, and then the x squared is in the second fraction. It's still equal to 1. That's always got to be the case in standard format. And we have that minus sign because we're talking about the hyperbola. Notice the a and the b are still in the same order. The a is part of the first fraction. The b is part of the second fraction. The only difference is those two letters have switched around. When the two letters switch around and now the y is first, because the y squared was before the subtraction sign, your graph is going to be drawn along the y-axis. You'll have a curve that is facing up, kind of looks like our parabola, then you'll have a curve that is facing down in the question. So a moment ago, I said the graph was formed between two curves that were mirror images of each other, and that's what it's going to look like in the picture, and that's in regard to whether the x is first or whether the y is first. If the x is first, draw your parabola, draw your hyperbola on the x-axis. If the y is first, then draw your hyperbola along the y-axis in our question. Now, a couple things I want to make note of before we actually get to do our examples today. To help us draw the hyperbola, we're going to have to use something that is called an asymptote. Now, we've talked about this idea of asymptotes before. It's just a straight line that my graph gets close to, but it never quite touches it. They're kind of guidelines, they're boundaries that we're going to use in this picture. These asymptotes are going to help me as we're drawing those U's, as we're drawing the curves into the picture, to make sure that I have it the right width in our problem. These two asymptotes that we're going to be drawing in are two intersecting lines, and as we're working through our questions here in just a moment, I have 3 examples that we'll do together. I'll show you how you're going to correctly draw in these asymptotes to help you know the width of the different curves that you're going to be putting into the problem. All right, so let's go ahead and put one more note here down. How are we going to correctly graph? And then we'll work through our examples together. The first thing that you want to do when you're graphing is to determine the direction of the hyperbola. Is it opening along the x-axis or is it opening along the y-axis? How do we make that decision? Well, which letter is first? If the first fraction contains the x, then your hyperbola is going to be along the x-axis. If the y is part of the first fraction, then your hyperbola is going to be opening along the y-axis. The second thing, determine the values of a and b. The a was always part of the first fraction. That will go with the letter in the first fraction. The b was always in the second fraction, and it matches up with the it matches up with the letter that's part of the second fraction. What you're going to do with those letters A and B is you're going to plot them along the X and the Y axis. So you go right, left, up, and down, so many spaces. And then we're going to draw a rectangle connecting those 4 different points. Okay, you may think, why am I drawing a rectangle? I'm supposed to be drawing curves. You'll see why in just a second as we're doing our example together. Okay, so pick out the A and the B from the question. Connect those 4 different points using your rectangle. Once you have your rectangle drawn in, here's where you're going to draw the asymptotes in the question. The asymptotes are going to be the diagonal of the rectangle. So connect the opposite corners. One goes from the bottom left up to the top right, and one goes from the top left down to the bottom right in the question. Again, the asymptotes are the guidelines that are going to help us as we actually draw the hyperbola, as we go to draw the U's or those curves for the final question that we have. Now, one thing that our problem is going to ask us to do at the end of the question after we graph is to write the equation of the asymptote. Now, the asymptote is a line. The correct format for a line is always going to be y equals mx plus b. Well, the plus b at the end, we don't have to worry about because these are all going to be centered at the origin. So what we're going to do is we're going to pick out the coordinates of a corner of our rectangle, and that's going to help us as we're writing down the equation of the asymptote. Again, as I'm doing my example, I can explain that a little bit better so you actually can see the picture than instead of me just saying too much about that right now. So we're going to pick out the slope from the origin up to that corner, and that's going to be what we're going to have to use in our line. In your work packet this week, you should have found a piece of graph paper. So if you want to get that out, you can follow with me as we're working through our examples together, and then you can use that as well as you're doing your homework that goes with this lesson. All right, so first equation that our job is to sketch, and then we're going to write the equations of the asymptote at the end of the question. That's always the last thing that you're going to do. So we have x squared over 9 minus y squared over 4 is equal to 1. Notice I know that this is a hyperbola because we have that subtraction sign in between the fractions, and it is in correct standard format because the question is equal to 1. The last example that we'll talk about today, the question doesn't equal 1, and we'll see how to fix that just like we did for our ellipse. So the steps that I want to follow. Number 1, I had to determine the direction of this hyperbola. Is it opening along the x-axis or along the y-axis? To make that decision, I look at fraction number 1. Fraction number 1 contains the x, so I know that this hyperbola is going to open along the x-axis. Those two curves are going to be on the left and the right-hand side of our picture. Step number 2 was to pick out the a and the b. The a is always associated with the first fraction. In the first fraction, I see the number 9. Now, the formula says a squared. So what do I square to get to the number 9? It is 3. So the a is going to be 3. The b is always part of the second fraction. Notice that's associated with the y here. Again, what did I square to get a 4? It is the number 2. So that was steps 1 and 2. We knew which direction it was going to open. That was based on the fraction, which letter was first, and I was able to pick out the a and the b. Those came from the denominator. Now, step number 3 said I'm going to draw in, or actually this is still part of step number 2. I'm going to draw a rectangle using these numbers a and b. How do I do that? The a for this fraction, because it's always part of the first fraction, is underneath the x. So in the x direction, I'm going to go right 3, and I'm going to go left 3. The b, it's always part of the second fraction. For this question, it's associated with the y. So back from the origin, I'm going to go up 2, and I'm going to go down 2 in my picture, and I drew a rectangle that was connecting those 4 different points. So notice here from the origin, because the x was first, and that is associated with the a. So 1, 2, 3 to the right, 1, 2, 3 to the left. The b, which was underneath the y for this example, was 2. So I went up 2, and I went down 2. So I made my rectangle connecting those 4 different points. Now we're ready for step number 3. After we draw in our rectangle, we're going to draw in the asymptotes. The asymptotes are the diagonals of those rectangles, and I drew them as dotted lines because they're technically not part of the graph. They're just the guidelines that we're going to use in the problem. Now, if you draw them with solid lines, it's okay. I'm always going to draw them with dotted lines in the problem. Okay, we'll write those equations in just a second that goes with those asymptotes. That'll be the last thing that we're going to do in our question. We're ready for the final step, number 4. We actually can graph the hyperbola at this point. To graph the hyperbola, we have to go back to our first decision as to which direction was it opening. Because in our question, the first fraction contained an x, we knew that this hyperbola was going along the x-axis. So I'm going to draw a curve over here on the left-hand side that will stay in between these two asymptotes. I'm going to draw a curve on the right-hand side, again, that will stay in between these two asymptotes, and that's what my final picture looks like. The pink graph is technically the final answer for the hyperbola. My green rectangle, as well as the blue asymptotes, are just the guidelines to help me get to those two graphs for the hyperbola. As you're drawing your hyperbola, get as close to these asymptotes and as close to the box as you can, but you don't want to touch either of them. Notice I did not touch the rectangle. I just came around and I got close to the rectangle. Then I came back down, and again, I got close to the asymptote, but I did not touch any of those pieces on the left or the right-hand side of our box or on the graph. The last thing that we had to do is actually write the equation of our asymptote. Okay, so follow with me to help us write the equation of the asymptote. All that we have to pick out is the slope, because both of these asymptotes hit at the origin, so their b value would be 0. We'll define slope. What's our definition of slope? Rise over run. So if I start at the origin, I would have to go up 2 spaces, and then right 3 spaces. I'm always going to go to the top right-hand corner, so I went up 2 and right 3. Well, rise over run then means that my asymptote is y equals 2 over 3x. The y is always going to come first. The x is always going to come at the end. You just have to pick out that fraction. Again, I went up 2, right 3 in order to get to that corner. Well, the equation of the second asymptote is just going to be the opposite, because I had to go up 2 and left 3 to get to the top left-hand corner. So I just slap a negative in front of my second asymptote, and that's my final equation in our problem. Now, I do want to point out, because maybe this will be a little shortcut or a little help that you can use as you're writing your asymptotes. The value of y, what's going up and down, is always going to be in the numerator, because rise always comes first. So in the question, if you look back at where the y was located, remember underneath it was the 4. Well, that represented the b value for what did I square to get the 4? It was 2. So the 2, or negative 2, came into the numerator. Okay, so whatever number is associated with the y in your question, that's where you're going to get the number into the numerator. The denominator in our slope is run. So rise over run, and run is along the x-axis. So if I go back to the question, underneath the x was the number 9. What number did we actually use in our question? It was a 3, because what did I square to get to the number 9? It was 3. So in our denominator, that's where the number 3 is located. Okay, so again, the number associated with the y is what goes into the numerator. The number associated with the x is what goes into the denominator, so you can correctly follow your rise over run format. Okay, so I got 2 more examples. Let's try these together. Again, we're going to sketch the hyperbola, and then we're going to see if we can correctly write the equation of our asymptote. So y squared over 4 minus x squared over 25 is equal to 1. This hyperbola is in correct standard format. It's equal to 1, and I know it's a hyperbola because there's a minus sign in between my 2 fractions. So walking through our steps. Step number 1, I had to determine the direction that this hyperbola was going. How did I make that decision? It's based on the first fraction, which letter is part of that first fraction, the y. So I know that this hyperbola is going to be open along the y-axis. There's going to be a curve that's going up, and there's a curve that's going down in our picture. The next thing that we had to know was the letters a and b. Again, the a is always part of the first fraction. B is always part of the second fraction. If I go to the first fraction, I see the number 4. So what did I square to get a 4? 2. In the second fraction, that's always where b is located, I see 25. What do I square to get to a 25? The number 5. Okay, so again, as I draw these into the picture, I need to make sure I'm using them correctly. The a is part of the first fraction that goes with the y. So I'm going to have to go up 2, down 2. The 5 was part of the second fraction, which goes with the x. So I would have to go right 5 and left 5. Okay, so please don't think the a always goes left and right and the b always goes up and down. It's depending on which letter is associated with. The a was the first fraction, which was the y. So those are going in the y direction this time. The b is always part of the second fraction, but the x is on this one. So I went right 5 and left 5. Okay, so let me go ahead and draw out the rectangle that I did. So from the origin, there's my right 5 and left 5 that we had for the b, because it was associated with the x. And there's my up 2 and down 2, that was for the a, because that was associated with the letter y. Now that I have my rectangle drawn in, I drew in my asymptotes next, connecting those opposite corners. The last thing is I'm drawing in my hyperbola. The hyperbola, where do I draw it? It's based on question number 1, the direction that it opened. Because the first fraction contained y, we know that this hyperbola is going along the y-axis. So there's a curve on the top, and there's a curve that's on the bottom. Again, I'm using my asymptotes as guidelines. I don't want to touch them. I don't want to cross over them. I'm going to stay in between them. And again, I don't want to touch this box. I want to get close to that box. That's another guideline that we have in this question. Last thing I want to do is write the equations of the asymptote. Again, if it helps you, go ahead and do it from the picture. From the picture, I'm starting at the origin, and I want to get to this top right-hand corner in my rectangle. Well, to do that, I'm following rise over run. So I would go up 2 spaces from the origin, and I would have to go right 5 spaces. So that means my asymptotes are going to be y equals 2 over 5x and y equals negative 2 over 5x. Again, if you want to follow the little shortcut, you go back to the equation. The numerator is always the number that was associated with the y. The denominator is always the number that was associated with the x. Back in our question, underneath the y was the number 4. Well, what number did we technically use then? It was a 2. So the numerator on both of these questions is 2. In the denominator, what number was associated with the x? That's where we use the number 5 within our work. So both of my denominators were 5 in our question here. All right, last example here. The last one that I want to do with you, this question is not in standard format. So we're going to do that first, and then we'll walk through the question about how to correctly graph like we've done in the last couple questions. So 4y squared minus 9x squared minus 36 is equal to 0. Remember, in standard format for the hyperbola, we have that minus sign in between the fractions, and our question always equaled 1. Well, right now the question equals 0. So the first thing I want to do is I need to take this constant, the minus 36, and move it to the right side of the question. So I added it over. So 4y squared minus 9x squared was equal to 36. We don't want any constants off by themselves on the left-hand side. All we wanted was those fractions on the left-hand side. The constant was on the right-hand side. Well, what are we missing to make this into standard format? We're missing the fractions. How do I make these into fractions? And I also have to have the equation equal to 1. I'm going to have to divide by that 36 that's on the right-hand side. We did the exact same process when we talked about our ellipse back from lesson 71. If I reduce each one of these fractions, so 4 and 36, well, those both divide by 4. So I made my first fraction y squared over 9. There's the minus sign, which I had to have if we're talking about a hyperbola. The second fraction, 9 and 36. Well, both of those divide by 9, so I made the second fraction x squared over 4, and now our question does equal 1, and we're in proper standard format, and we can continue to graph at this point. I cannot graph the hyperbola if it is not in standard format. Okay, so here it is, that equation that we just did. Y squared over 9 minus x squared over 4 is equal to 1. What direction is this hyperbola going to be opening? It's along the y-axis because I notice the y is in the first fraction that I have. The a is always part of the first fraction, b is always part of the second fraction. In the first fraction, I see the number 9, which means my a is going to be 3. In the second fraction, I see 4, which means my b is going to be 2. It's what did I square to get to those numbers. And think carefully, the number goes with that letter. The a was part of this fraction and is underneath the y. So we're going to have to go up 3 and down 3. The b was part of the second fraction and that's associated with the x. So we're going to have to go right 2 and left 2 to help us as we're graphing our rectangle. And notice I did that. There was our a, which went up 3 and down 3 because that was underneath the y. And here's the b that went right 2 and left 2 because it was associated with the x in our question. Drawing in my asymptotes, those two diagonal lines connecting the corners of the rectangle, and now we're ready to draw in the hyperbola. Where is the hyperbola located? It was on the y-axis because the y was first, so my two curves that are mirror images of each other are on the top and on the bottom. Again, I'm using my asymptotes as guidelines. It doesn't touch them, it just gets very close to those asymptotes as well as to my rectangle. Our last question, what is the equation of our asymptotes? Again, use the picture if we need to. I'm starting at the origin, and I need to get to this top right-hand corner. Well, again, all I need to do is pick out the slope. Slope is rise over run. So I would go up 3 spaces and right 2, which means my asymptotes are y equals 3 over 2x, and then put your negative on the second one because it's going in the opposite direction, y equals negative 3 over 2x. Our little shortcut does work. Again, the numerator was the letter from y, because y goes up and down for rise. The number associated with the y on this question was the number 3. The x is in the denominator, because that's the run, and x is what goes left and right. The number associated with the x on this question was the number 2. Okay, so what's a hyperbola? It's two curves that are mirror images of each other. They're in between these asymptotes. Those are the diagonal lines in this question. How do I know where to draw them? It's based on the fractions. If the fraction contains the x on the first one, then your hyperbola is on the right and the left-hand side. If the first fraction contains the letter y, then your hyperbola is on the top and the bottom because it's along the y-axis in your question.